Hey, so we're going to finish off this topic of polynomials with FOILing. So FOILing is really just multiplying, and it's multiplying binomials. So as we said previously, binomials are expressions that only have two terms. So two things are separated by a plus or minus. So we have something like 3x plus 7 and 2x minus 3. We can multiply it for the first time, same way we had done the previous. I'm going to take the first term, and distribute it, multiply it through. So if I do that, I'm going to take my 3x, multiply it times 2x, and get 6x squared. My 3x, multiply it times my minus 3 for minus 9x. My plus 7, so it's my second term, my plus 7, multiply it times my 2x, so plus 14x. My plus 7, multiply it times my minus 3, so minus 21. Combine like terms, I should get 6x squared plus 5x minus 21, since my only like terms was at minus 9x and at plus 14x. So the only reason we call it FOILing, because it really is just multiplying binomials, is because we have to do it a lot. You will be multiplying out binomials a lot, and so instead of saying, hey, multiply these two binomials together, we're going to say FOIL. FOIL just stands for first. So that's what we did. We multiplied the 3x by the 2x and got 6x squared. Then outer. Again, we did that. 3x times the minus 3 got us minus 9x. Inner. We did that. Plus 7 times 2x got us positive 14x. And last. Plus 7 times minus 3 got us to minus 21. So we already know how to FOIL. It's just a new term that we're going to use to multiply together binomials. So let's try a few more. So we have 2x minus 8 and 3x plus 2. If I multiply these together, I'm going to get 6x squared, my 2x times my 3x. My outer will be 2x times a positive 2, so plus 4x. My inner will be minus 8 and a positive 3x, so minus 24x. My last will be a minus 8 and a positive 2, so minus 16. Combine like terms. Again, the only like terms I have are those middle ones. So 6x squared will stay. 4x minus 24x will be minus 20x minus 16. They didn't combine any other terms, so that's it. Let's try it again with the 6x plus 1 and x minus 4. First would be 6x times x, so 6x squared. Outer would be 6x times a minus 4, so minus 24x. Inner would be plus 1 times x, so plus 1x. And last would be plus 1 times a minus 4, so minus 4. Again, combine like terms. 6x squared is going to stay. Minus 24x plus 1x minus 23x minus 4. No other like terms, so that's it. So there are a few special cases in multiplication. The next two rows are basically the two that we can think of, or that we're going to learn. So one of them is if you have the same exact numbers with opposite signs. We can still do this straight out just as FOILing. If I do this, I'm going to get 3x times 3x will give me 9x squared. 3x times a minus 2 is a minus 6x. Positive 2 times 3x is plus 6x. Positive 2 times minus 2 is minus 4. You see what happens though? My middle terms are the same, which kind of makes sense. I had the same numbers I was multiplying together. My outer was 3x and 2. My inner was 3x and 2. Only difference was the signs. So since they're the same, they're just going to cancel out. I'm going to get 9x squared minus 4. This last expression is actually called a difference of two perfect squares, and we'll learn more about that in the next topic. But I can do the same thing with this. 2x plus 5, 2x minus 5. I notice it's the same numbers around opposite signs. So I already know that my middle terms should cancel out. So if I want to, I can skip to the end and say, since my middle terms cancel out, I'm just going to multiply together my first terms, get 4x squared, and my last terms, minus 25. But to check, I'll go ahead and multiply it out. First, 4x squared, outer, minus 10x, inner, plus 10x, last, minus 25. They do cancel out, so we were correct. Okay, this is the other special case of multiplication. This one goes back to having something raised to a power. When we had a monomial raised to a power, we just went ahead and distributed that monomial, multiplied it times all the exponents on the inside. But this isn't a monomial, we have a binomial. So what I'm going to do is go ahead and write it out twice. So 3x plus 4 times 3x plus 4. So I'm going to multiply this together. I'm going to get 3x times 3x is 9x squared. 3x times 4 is plus 12x. 4 times 3x is plus 12x. 4 times 4 plus 4. Combine like terms, 9x squared plus 24x plus 4. So I can notice right away that it wouldn't have worked if I had just tried to distribute that 2. If I distributed that 2, I would have, missed that entire plus 12x and that plus 12x. There is a kind of shortcut for this if you want to memorize it. If you are squaring a binomial, all you're doing is you're squaring the first term, squaring the last term. So squaring the first term would have gotten us to 9x squared. Squaring the last term would have gotten us to the positive 4. And then you're multiplying the terms together and doubling it. So if we multiplied 3x times 4, we'd have gotten 12x. If we doubled it, we'd have gotten 24x. You can memorize that. That's lovely if you do, or you can write it out twice and simplify. Let's try the shortcut with the second one, and then we'll check it by writing it out twice. So if I do the shortcut, I'm going to go ahead and just square the first term. 2x squared would be 4x squared. Square my last term, minus 1 squared would be a positive 1. And I'm going to multiply the 2 together. So 2x times minus 1 would be minus 2x, and double it. So minus 4x. So we're going to see if that's actually correct. I'm going to write it out twice. 2x minus 1. 2x minus 1. And I'm going to multiply it. So I will get 4x squared. 2x times the minus 1, my outer, minus 2x. Inner would be minus 1 times 2x, and minus 2x. And last, minus 1 times minus 1, so plus 1. Combine like terms, my minus 2x by minus 2x should simplify to minus 4x. Okay, so really do it however you want. Now let's see if we can do the last one. The last one is x plus 6 times x minus 6 times x plus 2. So we're multiplying together 3 binomials. So we're just going to do them in order. It's kind of like if you had 3 numbers multiplied together. Say 5 times 2 times 3. You just do them in order. You multiply the 5 times 2 first and you get the 10. So we're going to do that first. We're going to multiply together the x plus 6 and the x minus 6. If you notice that you have the same terms around different signs, you can take that shortcut. You can square the first term, x squared, or just multiply together the first terms, multiply together the last terms, so minus 36. Knowing that those middle 2 terms are just going to cancel out. Okay, so if I was doing this with numbers, I would have 5 times 2 is 10, and then I would still need to multiply that times 3. So, doing it with algebraic expressions, I multiplied my first 2 together, and now I still need to multiply that times x plus 2. So we'll FOIL this first. X squared times x should give me x cubed. X squared times a positive 2 plus 2x. Inner minus 36 times x minus 36x. I missed an x squared, didn't I? Okay, so outer x squared times 2 would have been positive 2x squared. And then inner was still minus 36x. Last should be minus 36 times 2, minus 72. No like terms this time. So this is just done. Only thing where I sometimes see problems with this is do not get multiplication and your addition or subtraction confused. If you see a binomial, something like say x plus 3 plus 5x plus 6, do not try to FOIL them. They're not being multiplied, they are being added. In this case, you would just be adding like terms and getting something like 6x plus 9. So just keep an eye out for what operation you are actually doing. Okay.